Hi there, folks. This is the Practice Chapter 7b test. And as always, I am the amazing Mr. Jansen, so here we go. If I take a look at the first one, it's asking if the ordered pair is a solution of the inequality. So all I have to do is plug these in. And again, an ordered pair is x, y, so I want to plug the 2 in for the x and the negative 1 in for the y. So I have the absolute value of 3 times 2 minus 4 absolute value minus 2 times a negative 1. And now I want to see if that whole thing is greater than or equal to a 5. So now I need to simplify. Remember, absolute values, I start inside them just like parentheses. So I've got the absolute value of 6 minus 4. I'll wait and do this multiplication because I can. Now inside the absolute value, I subtract. That gives me a 2. So I have the absolute value of 2. Here I have minus a negative 2. 2 times a negative 1. And I'm going to do two steps here at once. I'm going to take the absolute value of 2, which gives me a 2. And now I'm going to change this to adding the opposite, because that's what subtracting a negative is. So that's a plus 2. And I want to know if that's greater than a 5. So it's 4 is greater than or equal to a 5, which is absolutely ridiculous. That is not true at all. So the answer here is no. Okay, it's not a solution. For this one, it says to write the equation in standard form of the line with slope of negative 2 and pass through point 3, negative 1. We know how to write this in slope-intercept, so I'm going to start there by finding the slope in the y-intercept. I've already got the slope. It's a negative 2. To find the y-intercept, I use a fresh y equals mx plus b, and I plug in what I know. I know that the slope is a negative 2. And now I have an x and a y value I can plug in, the 3 and the negative 1. So I plug in the 3 and the negative 1. And I solve for b. That's going to give me a negative 6 plus b, so I add the 6 to each side. So I find out that b equals 5. So now the equation in slope-intercept form, let me scoot this guy off to the side a little bit. The equation in slope-intercept form would be y equals a negative 2x plus 5. But I want it in standard form, so I'm going to have to add the 2x to each side. So in standard form, it's 2x plus y equals 5. So just be aware there are multiple forms that we can have this in, whether it's slope-intercept or standard form being ax plus by equals c. This one, it says to find the x and y-intercept of the equation. Remember to find the x-intercept. So we're starting with the x-intercept. I plug a 0 in for y. So I would have 3x minus 5 times 0 equals 30. Now I just solve this for x. That's a 3x equals 30. I divide each side by the 3 and find out that x equals 10. So that's my x-intercept. For my y-intercept, if I want to do the y-intercept, now I plug a 0 in for x. So I plug a 0 in for x, and I solve for y this time. So that's going to give me a negative 5y equals 30. Again, I have to divide each side, so I divide each side by the negative 5. So I find out that y equals a negative 6. Okay, so I've got my x-intercept, I've got my y-intercept, and that's it. And you can also think of these as the ordered pair. That's 10, 0, and this one is 0, negative 6. Okay? Number 4, it asks us to list the value of each from least to greatest. So I want to list these from least to greatest. So I just have to simplify this. Each of these, here I have the absolute value. 4 minus 5 is a negative 1, and the absolute value of that is 1. Here, the absolute value of a negative 7 is a positive 7, and then I tack on that negative sign. Here, the absolute value, this is going to be a negative 3 inside here, so the absolute value of that is a positive 3. For this one, that's going to give me a negative 2.5, and the absolute value of that is a positive 2.5. And then the last one, inside the absolute value, that's going to give me a negative 3. So the absolute value of that is going to be a positive 3, and then times the negative 2 is a negative 6. So now when I look at these, the smallest one is the negative 7. So this would be my first value right here. The next one is the negative 6. This would be number 2. Listing them in order. The next one would be the 1. So this would be number 3. Then the 2.5, number 4. And then last, the largest one is number 3, which is that. So in order, it would be the number 2, the number 5, the number 1, the number 4, and the number 3. Okay? This one, it says numbers that can be expressed as a fraction are known as blank numbers. Okay, the rational numbers are the ones that can be expressed as a fraction. Okay, so rational numbers. All right, the rational numbers can be expressed as a fraction. The irrational numbers, if we look at number 6, the irrational numbers are the ones that cannot be expressed as a fraction. Okay, so if you can express a number as a fraction, it's a rational number. If you can't, it means it's irrational. Those are numbers like pi, where we have never-ending, never-repeating decimals. For the other sets of numbers, the natural numbers or the counting numbers, that's the set of 1, 2, 3, 4, so on and so forth. Okay, it's the numbers that we use to count. The whole numbers are the same thing, but we include 0 now. So 0, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. And then the integers are essentially the same set once again, except I include the negatives now. So I include the negative numbers like -2, -1, 0, 1, 2, so on and so forth. And this continues in each direction because I include all of the positive and all the negatives. Okay. Then we would jump up to the rational numbers being expressed as fractions. We include the fractions. And then irrationals are the other side of that coin. Okay? In number 10, it says y varies directly with x and y equals 10 when x equals a -5. Find x when y equals a -12. And the hint here is to remember that direct variation is the form of the equation y equals k times x. So I'm talking about y equals k times x. All I have to do is find the k value here in order to find any missing terms. I'm going to write the equation. So when I do this, it told me that y equals 10 when x equals a -5. So now I just need to solve this for k. So I have 10 equals k times 5. I divide each side by the -5. And I find out that k equals a -2. So if my k value is a -2, it means my equation is y equals a -2x. And now to answer the question, it says to find x when y equals a -12. So plug a -12 in for y and see what x equals. I have to solve this. I divide each side by a -2. And I find out that x equals a +6. So again, I find the k value. I use that to write my equation. And then I use that to find the x value. Okay? In the next one, we want to simplify this. And anytime we're using rules of exponents, I should still follow order of operations. So as I look at this, I'm going to look inside the parentheses first. And inside the parentheses, I have division. So I'm going to do the divisions first. So x to the third divided by x to the, that's an x to the first down here. This guy right here, that's an x to the first. So when I divide, I subtract the exponents. So that's going to be an x to the second. For the y values, I have y to the fourth divided by y to the sixth. Again, I subtract the x value, so that's going to be a y to the -2nd. And now that whole thing is being raised to the -4th power. When I raise something to a power, I multiply the exponents. So that's going to be an x to the -8th, y to the +8th. And now the last thing I do is take care of negative exponents. I have to send that negative exponent to the denominator. So I make it y to the 8th over x to the +8th. And that's it. This one, it says exponential functions are of the form. Remember, any exponential function is of the form y equals a times b to the x. And remember, we just have some special conditions about the a values and the b values. B has to be greater than 0. A can't be 0. And b also can't be a 1. Okay? When the b value is greater than 1, this is a special exponential function, and that's our exponential growth. We're talking about exponential growth. When the b value is between 0 and 1, that's our other special case, which is exponential decay. And it's important to understand the difference between those things when you look at the equation. It's all based on the b value. If the b value is greater than 1, it's exponential growth. If the b value is between 0 and 1, it's exponential decay. So these says find the common ratio for each geometric sequence and determine the next term. Remember, a geometric sequence is just a sequence in which we're multiplying by the same thing each time. And that thing that we're multiplying by is called the common ratio. We'll call it an r value. So for this one, it looks like we're multiplying by a -3 each time. So the R value is a -3. 2 times -3 is the -6 times a -3 times a -3. So then the next term, if I multiply by a -3, is going to be a positive 162. And that's it. That's all it asks me to do. If I look at the next one, the R value, the thing I'm multiplying by, it looks like I'm dividing by 2 each time, which means I'm multiplying by 1/2. So the thing I'm multiplying by, the R value, the common ratio, is 1/2. And now to find the next term, I multiply it by 1/2 again. It equals a 4. This next one might be a little bit tricky. When we're looking at this, the R value might be a little bit difficult to determine. It looks like I'm dividing by 4 each time. And really dividing by 4, again, is multiplying by 1/4. So when I do that, if I keep multiplying by 1/4 or dividing by 4, the next value as a decimal is going to be a 0.1875. And that's it. All right, so again, if you see that you're dividing by something each time, it means you're multiplying by a fraction. In number 18, it says find the 12th term of the sequence. And it's given us the equation. When we're looking for the 12th term, remember this is my n value. So that's my n value. So I'm just going to plug that in for n and see what I get. So here I've got a of 12 equals 0.5 times 2 to the 12 minus 1. And really, I just have to make sure I do this in the proper order. Remember, since these are both in the exponent, it's like there's parentheses around it, so I have to do that first. So it's 0.5 times 2 to the 11th. And now here I have to do the exponent first, so I have to do the 2 to the 11th power, which gives me a 2048, and then multiply that by the 1/2. So just make sure you're following the order of operations when you do this. You get the 1024. Okay? For these, it asks us to find the amount in each account given the following conditions. And the first thing we notice when we read the problem says $500 at 4% compounded monthly. And that word compounded means I have to use a special formula. I'm using the formula A equals P times 1 plus R over N raised to the NT. As soon as I see compounded, that it's compound interest, this is the exponential formula that I want to use. All right? P is the principal, so the amount in the account is going to be P, which is the 500. It's the initial amount, times 1 plus R, written as a decimal, which is 0.04, over N, which is the number of times each year it's compounded. So since this is monthly, that's going to be 12. Raised to the N, which is 12 times T, which is the time in years, which is 5. And now again, I want to follow order of operations, so make sure you start inside the parentheses. I'm going to do the 0.04 divided by the 12, and then add the 1. And then I'm going to raise that to the 60th power, and then multiply it by the 500. Okay, so make sure you're putting this in the proper order. And remember, we don't want to round this off until the very end, so we kind of want to put it into our calculators all in one shot, and it gives me $610.50. So make sure you're not rounding that off until the very end. Same thing with the next one. Once again, it's compound interest. The principal is the 3,500. We've got 1 plus 0.06 divided by, it's compounded quarterly, so that's going to be a 4 this time, raised to the 4 times 10. And now again, I have to punch this into my calculator, so I do the 0.06 divided by the 4, I hit enter. Then I do the plus 1 and I hit enter. Then I raise it to the 40th power, hit enter, and then multiply by the 3,500. So when you're punching this into your calculator, be careful, or use parentheses as you punch this in to make it a little bit easier on yourself. So it looks like I get $6,349.06. Okay?